Hello and welcome back to your Comp Sci Tutor. Today we're going to have a look at something which many GCSE students struggle with or are a little bit afraid of, trace tables. So yeah, if you're not sure about trace tables or if you've practiced it before but you're not too confident with it, then hopefully this will help clear things up a little bit for you. So this is something that comes up in the GCSE and the A level. And essentially, we're going to look at the basics today. If you can get the basics down, then you can do essentially any trace table because they all work the same way. We're just going to run through some code. So before we look at a real example of a trace table, we're going to look at what actually happens when code is executed. So in this example here, and this isn't how you'd complete a trace table, this is just kind of an abstraction to show you what is going on. We're going to show what's happening inside the CPU in this box here. We're going to show what's happening to a variable called number, what values are being assigned to that variable in this box. And then we've got an output box. So this is your console window if you're using Visual Basic or C Sharp. And it's your shell if you're using Python. So whatever is being output by the program. Okay, so what happens is when we execute a program, the computer runs through it line by line. Okay, so here we've got number equals 6. Okay, so I'm going to use the word equals for that arrow sign. The arrow is there for variable assignment. In most actual languages, this is pseudocode, but in real languages, every example I can think of uses just an equals for assignment. So here this is saying that the number 6 is being assigned to the variable which is called number. Okay, so that's all that's happening there. We don't have to do too much. There's no calculations really. We're just going to put the number 6 into the number variable. Okay, and that line of code is complete. So now we move on to the next line of code. We've got number equals number plus 4. So there's two steps to this one really. First of all, our CPU needs to do this calculation. So number plus 4. Now number is referring to whatever is stored in this number variable, which is currently the number 6. Okay, so number plus 4, our CPU will take that number of 6, add 4 to it, and then calculate that that is 10. Okay, and then the second part of this line of code is we need to take that answer, which is 10, and store that in the number variable as well. Now we can't store two different numbers in the same variable, so what happens is the number 6 will essentially be overwritten. It won't exist in the number variable anymore, but 10 will be. It will be there. Okay, so 6 disappears, that gets overwritten by the number 10, and once we've done those two steps, now that line of code is complete. Then we get the next line of code. We've got number equals number times 2, and it's a similar situation again. The first thing we need to do is our CPU is going to execute this part of the code and figure out what this calculation is. So number times 2. Now remember, when we looked in number last time, it was 6, but it's not anymore. Now number is 10. Okay, it's only holding one number at a time. Now it's holding the number 10, so our CPU is going to need to do 10 multiplied by 2, which gives us 20, and then same as before, our next part of this line of code that we're executing is we need to store that answer, so the 20, into the number variable. So again, it's the number variable is storing the number 10 at the moment. That's going to need to go because now it needs to store the number 20. Okay, so we can see it was storing 6 now, so then it was storing 10, and now it's on 20. And then our final line of code for this example, output number. Okay, so now we've got the output command. That means that this is going to be output. Now we're not outputting the word number here. It would need speech marks around it for that. What this means is, again, we're going to look into that variable. What is it storing at the moment? It is storing the number 20, so we're going to output 20. Okay, and that is the final line of code. So that program has been executed. Okay, there's no more lines of code. So all our CPU, all our computer has done is gone through one line at a time and just execute each line of code sequentially, so in sequence. So that was an example of how programs are actually executed by our computer. When we complete a trace table, we write it slightly differently because we record every step. And the only real difference, as you can see in this example, we've got the trace table here on the right-hand side. We've still got the number column, where we're going to record what's being stored in that variable, and we've still got the output column where we're going to record anything that is output by the program. The only difference is the CPU box that was in that previous table has gone, because what's going to happen is essentially when you run through this code, you are being the CPU. You are doing the calculations and working out where to store these values. Now, this is exactly the same code as we've just looked at. So it's going to do exactly the same thing. We know the number is going to store 6, then it will change to 10, then 20, and then we'll output 20. But this time you'll be able to see how it actually looks in a trace table. Okay, so what we need to do, and this is a tricky bit, this is what some students struggle with, where there's lots of lines of code, we just need to do what we did in the last example and just look at one line of code at a time. So what you can do is you can cover it up. If you've got a piece of paper or a ruler or something in your exam, you can cover up everything so you can just focus on that one line of code, because that's how our CPU would execute the program. So the first line, we've got number equals 6. Okay, so we just put a 6 into the number column. Now we start at the top and we work our way downwards as we go through the program. So that's line number 1 completely finished. We tick that off. Then next we've got number equals number plus 4. Okay, so this is where you would have to be doing the job of the CPU and working out what number has stored in it, in that variable, which is number 6. Add 4 to it, calculate that that is 10, and then you can see that's being stored in number. Now, instead of crossing out the number 6, we would just write the number 10, the new value that number is storing, underneath in the next row of the trace table. So it was storing 6 at the top, now it's storing 10, and then we move on to the next line of code. So number equals number times 2. So we look at number. Now, even though we haven't crossed out the number 6, it is no longer storing the number 6. The current value of the variable would be the one that's lowest in the trace table. So if we start at the bottom and look up, we can see that number is currently storing the number 10. So we would do that, multiply it by 2, and that would give us the number 20, and that gets stored in number. We can't store anything in the same box as the number 10 or the number 6. It's going to go underneath to show that that value has been updated. And then we've got the final line of code, which is output number. Okay, so we're going to look again from the bottom up. So if we start at the bottom, we go up and we find the number 20 is the previous, so the most recent value that we've entered into that column. So that is the current value that number is storing, and so we would output that. Okay, now I've put it underneath here on the last line of the trace table. If you put it next to the number 20 in that same row of the table, you wouldn't lose marks for that. That's absolutely fine as well. I just like to go from the top downwards, because essentially what we have as we run through the code and as we run through our trace table, it's almost like time is passing. So we start at the top, and then as we get down through the code, things get added underneath, and so it's like time in our program is passing, and what happens at the bottom is the most recent, and at the top is the first things that happened in the program. Okay, so we've got an example here. We've got 1, 2, 3, 4, 5, 6, 7 lines of code. Okay, we can see we've got a few outputs, we've got a few variable assignments. Now what I would do in a lesson is get you to do this on whiteboards. So what I would do now, if you're watching this video, is if you've got a pen and paper, or if you have got a whiteboard, just quickly sketch out that trace table and then have a go. So run through line by line, and then pause the video so you can see once you have executed it, and then I'll run through the answers so we can see if you've got something similar to me. There is a little trick with this one, it's a little bit tricky, but have a go. So if you pause the video now, and then in a couple of seconds I will put the answers up. Okay, so let's see how you did with this. So we should have something that looks a little bit like this. Okay, don't worry if you've used different lines on your, different rows in your table. But let's have a look at this and see how it works. So the first line of code, we've got day equals Saturday. So I've put Saturday in here. We don't necessarily need the speech marks that exist in the code. You wouldn't lose marks for doing that in an exam. It just shows in the code that that is a string, so that is going to hold a sequence of characters. We don't necessarily need to do that in our trace table, but if you have put the speech marks, don't panic. So that goes into the first row of the day column, because the variable day is storing that value. It's been assigned the value Saturday. Second line of code, we're going to output day. Now this is kind of similar to last time where we output number. We're not going to output the word day because it's not in speech marks. We're going to output the value of day, which at this point in the program was Saturday. So we output Saturday as well. Then the third line of code, we've got day equals Sunday. So that goes underneath where day was Saturday, okay, because that's a recent update that overwrites the value of Saturday and becomes Sunday. Then the fourth line of code, we've got output day again. So now, because day is storing the word Sunday, we output Sunday. Then the fifth line of code, day changes to Monday. Day is assigned the value Monday, so that overwrites Sunday. Monday goes there. And then the next line, this is where it gets slightly trickier, we've got output new week. So if you spotted the pattern that it was just outputting the same day that was being stored in the variable, this is where you might have gone wrong. But this time it's going to output new week first. Okay, that string, it's got nothing to do with the variable, okay, which is why it's in speech marks. So that gets output there. And then our final line of code, we've got output day. So if we look up from the bottom of the table, day is storing Monday. So that gets output there underneath. Okay. Right, so this time we've got an if statement. So again, I'm going to get you to have a little practice with this one. Now, the trick with if statements is that even though it seems like lots of code, and this is a very small if statement, but there's still 5 lines of code in our pseudocode example, we only actually have to execute really one of those outputs. Okay, in this case, if the number is less than 10, we'd output number. Otherwise, if it's not less than 10, we'd output the number divided by 10. Okay, so it looks a bit scarier because there's more code, but there's actually not as much to do as far as we're concerned. So what I would like you to do, again, you can pause the video, but complete the trace table for this algorithm, but you need the value that the user is going to input on line 1. So for the user input, for this one, the user is going to input the number 5. Okay, so what I'd like you to do is just have a run through of this and then pause the video. In a couple of seconds, we'll have a look at the answer. Okay, so let's have a look. So not a lot to this one in terms of what we have to write in the trace table. So the number we said the user input was going to be 5, so that gets stored in the number variable on line 1 of the code right at the top. And then we get our if statement. So if the number is less than 10 and 5 is less than 10, so we output number, so we output 5. And because we completed that part, because we executed that part of the if statement, we can ignore the else and we jump straight down to end if at the bottom of the code, and there's nothing after that, so that's it, we've finished executing the program. Okay, so have a go with the same code, exactly the same code, same trace table, but this time what happens if the user enters the number 26. Okay, so again, pause the video, and then once you've had a go, then you can press play and we'll see if we've got the same answers. Okay, let's have a look. So this time we said the user input was going to be 26, that gets stored in the number variable. And then if number is less than 10, which in this case it isn't because 26 is obviously greater than 10, so we skip the first part of the if statement. Instead of outputting number, we jump down to else. Okay, so if it's not less than 10, then we execute this second output line of code here. So we output number divided by 10. So we do 26, which is the current value of number, divide it by 10, which gives us 2.6, and that is what is output. Then we hit end if, and that is the end of our program. Okay, so just one more example for this. Okay, same code again, potentially a slightly trickier one. So complete the trace table, same code. This time, if the user enters the number 10. Okay, so again, you can pause the video, and then in a couple of seconds, we'll run through the answer. Okay, so like we said, the number for the user input was going to be 10 at the top, so that gets assigned to the variable number. And then this time, we actually execute the second half of this if statement because 10 is not less than 10, it is equal to 10. So the first part is not true, number is not less than 10, so we execute the statement that is after the else part of the if block. So we've got output number divided by 10, number is 10, 10 divided by 10 is 1. Now I've put 1.0, if you just put 1 that would also be absolutely fine. If you're using something like Python, a language like Python, it will automatically convert it to a float, to a decimal value, because if we're using division, it's likely that we're going to end up with a decimal value. So I've put 1.0, but like I say, 1 would be absolutely fine. Okay, right, so we've got a bit more of an involved example here. So I'll run through this one line by line, and then I'll give you another practice one to have a go at afterwards. So a bit more code here, and this time, as well as the if statement that we've got later on, we've also got a for loop. Okay, so loops are the only other tricky part of trace tables because it means we need to repeat some code. We've got some iteration here, which means we're going to execute some lines of code more than once. So let's have a look. Right, starting right at the top, we've got score equals 100. So in our trace table, we've got two variables. We've got I, which we'll come to later, and score, and then we've got an output column as well. So score equals 100. We put the number 100 into score. Okay, and that goes at the top of the score column. Right, then our next line of code says for I equals 1 to 4. So in this case, I is essentially a variable. It's going to be used as a loop counter. That is going to store the values 1, 2, 3, and 4 in that order. Okay, and then during each iteration of this for loop, we're going to execute the line of code that's inside the for loop. But what you don't want to do here is just write 1, 2, 3, 4 in the I column, because if there's more things that are happening inside the for loop, then that's where things can go wrong, and you end up with data in the wrong place in your trace table. So we just need to execute it one line at a time, just like the CPU would, and just like we have done for the other examples. So on that third line of code, if we ignore the blank, for I equals 1 to 4, I is 1. I has assigned the value 1 to begin with, and then we enter the for loop. So the next line of code says score equals score divided by 2. Okay, so score is currently 100. We divide it by 2, and then we store that value in score. So 100 divided by 2 is 50, and that value gets assigned to the score variable. Now I put it here, partly because it's the one directly underneath the 100, but also it's in line with I being 1. So when I is 1, score changed to 50. Okay, so that's kind of in line now, and it makes it nice and easy to follow. Okay, then the next line is end for. So at that point, this is where we need to jump back up to the start of our for loop and see if we need to iterate again. So I is going from 1 to 4. I is 1 at the moment. It's going to keep going until it gets to 4. It's not 4 yet, so we need to add 1 to I. So I changes from 1 to 2. And then we enter the for loop again. So score equals score divided by 2. So we're going to be doing this pattern over and over again. This is quite a simple for loop. So score is currently 50. So 50 divided by 2 is 25, and that value gets assigned to the score variable. That happens when I is 2, so I'm going to put it alongside I being 2, and it's underneath the 50. Then we hit end for, so we jump back up again to the top of our for loop. I is going from 1 to 4. It was 2, so now it's going to be 3. And then we enter the for loop again. Score equals score divided by 2. Score is currently 25, so we divide that by 2. That's going to give us 12.5. And then that gets assigned to the score variable, so that goes there. And then we hit end for, and you can probably guess what's coming next. We need to jump back up. I is going from 1 to 4. So far we've done 1 to 3, so that needs to change to 4. This is going to be our last iteration. And then score equals score divided by 2. So score is currently, if we look from the bottom of the table upwards, score is currently 12.5. Divide that by 2, gives us 6.25, and that gets stored in the score variable again. Okay, then we hit end for. Now at this point, what our CPU would do, if we were actually executing this code, is it would jump back up and see if I needs to change again. Okay, so it's a good idea that we do that. So we look, I is going from 1 to 4. We've done 1, 2, 3, and 4 in our I column. So we've done 4 loops of this for loop, this iteration structure. Now we've hit end 4 for the final time, we can drop down to the if statements underneath it. Okay, so if score is less than 10, and like we said, we need to work from the bottom up. Score was 100 to begin with. It was 50, it was 25, it was 12.5. It's not any of those values anymore. The current value of score is 6.25. So 6.25. If 6.25 is less than 10, which it is, then we need to output oh dear. So we output oh dear, and then we can ignore the else part of the if statement. Okay, so we jump down to end if, and that's the end of our code. Now, like I said, time kind of passes as we move down through our trace table. So we've got 4 iterations of our loop on 4 separate lines of the trace table. And then because the if statement is after the for loop, I've put the output of oh dear on the line underneath in the trace table. Okay, now you could put it above, but I like to keep it separate so that the for loop is separate from what comes after it, and we can see that kind of passage of time going down through the trace table. Okay, so this is some very similar code. Okay, it's slightly different in that the starting value has changed. So now score is 400. So have a go at this example, pause the video, and then we'll see what the answer is afterwards. Okay, right, here we go then. So pretty similar to what we had before, but this time because score started at 400, it got halved during the first iteration of the for loop to 200. Then during the second iteration, that gets halved again to 100, then to 50, then 25. And then when we get to the start of the if statement, 25 is not less than 10. So we don't execute the first output. We jump down to else and execute the second output. So it says well done in the output column. Okay, and well done if you got that. Okay, slightly different code this time again. Not only is the score value changed, but actually what's happening inside the for loop is different. We've got a slightly different loop counter. We've got j instead of I, and the if statement is slightly different as well. Okay, so have a go at this one as well. Pause the video, and in a couple of seconds we'll have a look and see if we've got the same answers. Okay, here we go. So this is what I've got. So score is 1 to begin with. During the first iteration of our for loop, score gets doubled to 2. Then the second, it gets doubled to 4. Then it gets doubled to 8. And then it gets doubled to 16. And then when we get to our if statement, if the score is less than 30 and 16 is less than 30, then we output unlucky. We don't then output great because that's in the second half of the if statement, which we can ignore because we've executed the first part of the if statement instead. Okay. So that is it. Hopefully that's been useful. Okay, if you want me to have a look at any other trace table examples, the only other tricky part would be to do with arrays, then let me know. And otherwise, I will see you soon.